Okay, this is practice of exactly like the type of problems that you're asked to do on your homework. So there are 7 problems here. Each one of them represents one of the 7 types of chemical reactions that I went over in the notes. Suggest you take a look at the PDF file, try these problems yourself first, and then watch this video and see how you did. All right, so let's do these one at a time. Okay, now the first one, we have a hydrocarbon and oxygen. So that is a combustion reaction. So I'm using the codes that we have in each one of the types of reactions. So combustion is C. Now for a combustion reaction, it will always produce carbon dioxide, the gas, and water, which is a liquid. To balance the reaction, we have 5 carbons here. So we need a 5 here. We have 10 hydrogens. So over here, we need to put a 5 here. Give 10 hydrogens, but we have a little bit of a problem. This gives us 10 oxygens. This gives us 5 oxygens, so it's 15 oxygens. And so we can't do that by putting in a whole number here. So remember that trick: when you can't balance a diatomic element, balance everything else and then double the coefficients. And so if I make this a 2, and then change these 5s to 10, then I can balance it by making this 15. 15 O2s gives us 30 oxygens. You have 20 oxygens here and 10 oxygens here. So that's your balanced reaction. Next, this is a single replacement reaction. You recognize it because you have aluminum, or sorry, you have an element reacting with a compound. So in that case, the aluminum, when it becomes an ion, becomes a cation. So this is a single replacement cation. Single replacement cation. So what happens in the reaction is that aluminum takes the place of zinc to form aluminum chloride. Aluminum has a positive 3 charge, chloride a negative 1. And that's going to be aqueous. Now notice the note up here. Unless stated otherwise, all ionic compounds will be aqueous. So aqueous. And then zinc will be by itself. Zinc is a metal, so it's a solid. To balance the reaction, we have 2 chlorines here, 3 chlorines here. So think least common multiple, which would be 6. So this would be a 3, and this would be a 2. So to balance the aluminums, to balance the zincs, and that would be it. By the way, it doesn't matter the order that I put it in. You could have put the zinc here and then the aluminum chloride here. That doesn't matter. Okay, next. This, you have 2 aqueous compounds. So 2 aqueous compounds is a double replacement reaction. And it tells you the hint here that the product with calcium will be a solid. So this is a double replacement reaction, and a solid will be forming, and a solid we refer to as a precipitant. So this is a double replacement precipitation reaction. So in a double replacement reaction, the ions swap partners, as it were. So calcium sulfate, calcium's a positive 2, sulfate's a negative 2, and it tells you in the hint that that's going to be our solid. The product that has calcium is a solid. And then ammonium nitrate. Ammonium's a positive 1, nitrate is a negative 1. Now, so again, all ionic compounds will be aqueous. So what's the state of this, or phase? Aqueous. To balance it, we have 2 ammoniums here, 2 nitrates here, so we just need to put a 2 in front here. It's balanced. Next, Okay, this has one product. So one product is a synthesis reaction. And so all we need to do is look at the elements and write those as our reactants. So chromium, it's a metal, it's a solid, and oxygen is a diatomic gas. To balance the chromiums, no, let's do the oxygens first. You have 3 oxygens here, 2 oxygens here. So again, the least common multiple is 6. So it's a 3, it's a 2, which means I would have 4 chromiums here. Reaction type is synthesis or combination. So it's balanced. 5. Okay, now this, you have a halogen reacting with a compound. And so that's going to be a single replacement reaction, but because halogens become negatively charged, they're anions, this is a single replacement anion. So the bromine is now going to be alone. It's a diatomic liquid. And the chromium will then be bonded with the fluoride. Remember, unless told otherwise, ionic compounds will be aqueous. Okay, now the chromium here, chromium could have a positive 2 or a positive 3 charge, but we know that it's the positive 3 because we have 3 bromides, and bromides are a negative 1 charge. So the metal's not going to change its charge in this reaction, so that's why it's still chromium 3. So this would be chromium 3 fluoride. To balance the reaction, you would need, again, for both the bromine and the fluorine, at least common multiple would be 6. So I need to put a 3 here and a 2 here. That'll balance the fluorines. And a 2 here and a 3 here to balance the bromines. That'll give us 2 chromiums, which is what I have here. So that would be balanced. 6, okay, you have a single reactant. So anytime you just have one reactant, that's going to be a decomposition reaction or analysis reaction. Decomposition. Okay, so all we need to do, and these are really quite simple, is just break it apart. Sulfur is a solid. How do you know it's a solid? Look on your periodic table. It tells you it's a solid. And again, oxygen, our favorite element, diatomic gas. Balance the oxygens. Balance the sulfur. Voila.
Okay, now wait a minute there, Mr. Massey. That was not a balanced equation. Let's try that one more time. We have 2 oxygens here, 3 here, so the least common multiple would be 6. So we'd want to put a 3 here and a 2 here. That would give us 6 oxygens on each side. To balance the sulfurs, we need a 2 here. That is our balanced equation. All right, back to the video.
And last, okay, now this is an acid reacting with a base. So you should recognize this is an acid, and all you need to know, as I said in the notes, about determining if something is a base is if it has the hydroxide ion. If it has the hydroxide ion, it's a base. And so this is going to be a double replacement neutralization reaction. You may have heard somewhere that an acid will neutralize a base, or maybe a base will neutralize an acid. So this is a double replacement neutralization. And in that, you're going to form an ionic compound, be barium nitrate. Barium has a positive 2 charge, nitrate has a negative 1. It'll be aqueous. Remember, unless told otherwise, ionic compounds are aqueous. And water. So anytime an acid reacts with a base, it'll form an ionic compound and water. To balance the reaction, we need to put a 2 here. That'll balance the nitrates. And you have 2 hydroxides here. So on this side, you have a total of 2 hydrogens and 2 hydrogens. You have 4 hydrogens on this side, so we need to have a 2 here to balance the hydrogens. And that'll balance the oxygens, 2 oxygens here, 2 oxygens here. So that knows the hydroxide no longer is around after the reaction, but nitrate is. So that's why I'm not looking at that oxygen. I'm just saying. Okay, and that would be balanced. And that's it. Okay, again, this is exactly like the homework. You have 18 of these to do on your homework. Okay, that's it.